Okay. Hi everyone and welcome to Applifting. This is our first crew talk of the year where we share our insights and insights of our partners and clients about everything software related, everything developer related. And our first crew talk of this year is challenges in backend architecture. It will be all about mostly backends, mostly solution architects, mostly microservices, mostly sagas, outboxing patterns, and all that good stuff. So, my name is Vráťa Kalenda. I am the co-founder in Applifting, and I will be hosting this event for you today. Just a short info about where you are. You are in Applifting. That's a software development studio. We create digital products, both on desktop and mobile, for both startups and enterprises and associated services. We are a weird company in a way that we are what is called a teal company. That means no managers, open salaries, people see our bank account, and our board of directors is elected by our colleagues. So if you want to know more, just stop me or any uplifting colleague, and he will tell you more about the weirdness. And we are always for the lookout on the bright solution architects and backend developers. So, and now, our first speaker of the evening is Nikolai, and Nikolai will be telling the tales of two generals, also known as the problem with microservices. Before he will come to the stage, here's a Slido. I would love you to all scan that QR code when you see it, because afterwards you won't see it. So please do it right now, so that you can ask Nikolai very hard questions that he will love to answer. Yeah, you know, in Applifting we are all about security and auto-locking our computers. So, and come on, work. The way how we will structure this evening is we will start the talks. We will have 2 talks, then possibly a break. Then we will have a networking, you know, backend to backend engineers talk. That will be fun. And then, who would like to see our offices? I will personally, you know, show you around. And we can be here, let's say, until 10 o'clock, and afterwards we can move to a pub. Sounds good? That sounds like fun, right? So let's do it this way. And now, give a clap to Nikolai and his microservices talk.
Hello, guys. They said I have to put it really close to my mouth, so it's not comfortable for me. Anyway. So you was promising to talk about outboxing pattern. I lied. I decided to start actually a bit higher on this topic and start with more theoretical part of like why this outboxing pattern even exists, and only then go to it and maybe demonstrate you some examples, because in a nutshell, actually outboxing pattern is quite simple. So, a bit about me. I don't know, I'm 10 years in IT, last 7 usually doing some tech leaders role, architects, and was working in this kind of wide range of industries, media, fintech, domain, but I think it's kind of common in the all IT guys. And usually I'm doing like backend, front end here with a spark of DevOps and a bit of a hybrid mobile development, but most of the time I'm trying to figure out some good solution architecture for our partners. Right, I already said everything about us. Should I repeat? Okay, I'm gonna skip it. So today's topic, I'm promising we're gonna go into the outboxing patterns on all of this, but first let's actually define the problem space and why is this problem even exist in the first place. And then we're gonna be tackling it more like a practical approaches, how we can apply it into real life engineering rather than just like some mathematical concepts. So, like I was saying, today is like 2 generals. What the heck they have to do with microservices? So, let me tell you a story. Imagine yourself, you're playing Heroes of Might and Magic, and you have 2 generals, and they need to attack for a castle. The issue is that is that attack gonna be successful only under the condition that both generals gonna attack the castle in the same time. In any other configuration, they're gonna fail. And why it's not working? The good part is, the generals are at some distance from each other, and they can exchange messages. For example, with, I don't know, pigeons, or some other guy sending a message. I don't know if you like Twitter, maybe. But there is a problem. Again, there is an enemy army in between of the two generals. So any message can be captured and, well, not receive its original intention. So let's take a look at this problem in a more like classical diagramical way, you know, UML and shit. Anyway, so let's imagine the first general sends a message, let's attack on a 1st of January on year 70. But if you will think about it, there could be two outcomes of this operation. One is the message did not receive the target general. But there could be even worse situation. The message was received by the second general, but we don't know about it because the message back was captured. And the problem is that from perception of the first general, it's pretty much the same. You don't know the outcome of the operation. And speaking about a more practical part, this is actually the main reason why on a network, like returning back to the real world network and stuff, why exactly once message delivery is pretty much not possible. Network is doesn't designed like this. So what a potential solution? Let's think about it. So first option, let's use just a spam. So the first general will always attack and just like send messages, let's attack with me, let's attack. Well, but in this configuration, we doesn't guarantee that any of the messages is going to be receiving the target. So we still can go and fight alone and lose the battle. So another potential solution, let's do it vice versa. The first general going to be sending and will be waiting till the second general will confirm that he's going to be participating in a battle. But if you will think about it, now second general is in the same position as the first general was at the beginning. And the truth is, this mathematical concept has pretty much no solution. There is no solution how you can solve this problem. And this is where we have a really interesting outcome. Like in any distributed system of any kind, there is no way for one node to know exactly the state of another one. And that leads actually to more like well-known concept. It's called CAP theorem. Who knows about CAP theorem? Oh, come on. In any case, let's think about it like for those who are like not aware of this concept, like pretty much it states that like in any system you have like three main parameters. So you have consistency, availability, and resistance to partitioning. And the problem states you can only select two. You cannot have all three. And if you'll see it from the practical perspective, it's actually exactly what's happening with all the databases we're selecting. So for example, your classical RDBMS system, like Oracle, MySQL, it's pretty much here. Everyone can write, everyone can read, try to scale it. Well, I need your PhD and probably some antidepressants to do it. On the other hand, you have Cassandra. Super scalable, partitional tolerant, super available, everyone can read about it. The problem is, if you're not guaranteed that you're going to read the same data as another node. So you don't have the same view. Or, for example, the classical example from the CA perspective is Redis. Again, super scalable, all the clients see the same data, but you can write only into the master node. So they're pretty much, writing is not scalable here. Just to give some like heads up, this problem is actually a subset of another problem, I think mostly known for the guys who are into crypto, is a Byzantine general problem. It's the same thing, but there is more generals, and one of them is a traitor. And I think the guys kind of found the solution, which is called like proof of work or proof of stake. It's more like a social engineering solution, but that's how we get a crypto. Okay, so that was a fancy theory, but like we are not a scientist here, we're engineers. So we need to figure out the solution, what we need to do with this problem. So let's find some pragmatic approach. Because after all, Netflix is working, I don't know, YouTube is working, Google is working, there is tons of systems that use distributed system, and it's somehow working despite the obvious inability to solve this mathematical concept. Well, there is a solution, but we need to change the problem. And there is pretty much two adjustments that you can make. First, we don't care if the message was delivered. That's called fire and forget usually on a slang. And the second one, we don't care when the second general gonna receive a message. That's called eventually consistency. So another way how to put it is if we don't care if, it's called at most once delivery. So we just send in a message and we don't care if someone's gonna receive it or not. And there is tons of application of such pattern. Your classical REST API with your SPA, with a front end to mobile, this is exactly it. It's totally sufficient. If something gonna web sideways, user can always refresh the web page or just refresh his mobile application or just demonstrate some error into the user. Another good application to this, well, let's say you're developing a Starbucks application and you have some kind of rewards service. It's definitely important for the business to log all the rewards and benefits user got from buying a Starbucks cappuccino, but it's not kind of important for receiving notification. You're kind of fine it's gonna fail, so it's kind of easy and cheap and we can use this method to apply notification service. Another one, if we didn't care when, it's called at least once delivery. So we definitely guarantee that message gonna be reached eventually the target. We just don't know when. And this is a bit more complex example. So where it's usually applied, let's imagine you can have some kind of a user service and then you have user history service that logs all the changes into the domain of user. So you definitely want, with max probability, to have the history of a user. And at this moment, you have no other option than apply at least once delivery. Sorry, I was confusing them. How it's usually done? Well, you can just spam the REST API on repeat until you will not get confirmation, or just use a freaking Kafka or some other messaging services that of your preference. So usually, I think a common pattern, we have some kind of a service who sends message through message broker messages to another one. But we live in a distributed world, meaning that pretty much anything can fail at any point of time. And we're pretty much aware that our services can fail for some particular reason. Our database can fail. Even potentially our message broker can fail. And I think everyone is well aware of this. But actually what most people are kind of not thinking about it, even though like modern tech like Kafka can compensate for this, between your service and your message broker, there is also a network applying the same rules as we was learning before. So let's think about this problem in a real life scenario. So we need, let's say, update the user and then publish some kind of event to the user history service, and we absolutely must log it. So how we should do it? Should we like store the user in our database and then send a message to Kafka? But in that manner, like who guarantees that the message gonna be even reaching the Kafka? Like something can go sideways. Another option, we can publish an event, like, hey, user was updated, but who guarantees you that the commit will not be rejected by that database? So in this manner, you can get really easily inconsistent state between two of your services. One gonna be having the change, and another one will not be aware of this change. So the solution, actually I was promising that we will get to this, is exactly outboxing pattern. There is a lot of different realizations. There is some software, like for example, Debizium, who can help you with that. But in a nutshell, it's a really easy idea. if you have two separate transactional contexts, then you can still unite them by single one, like the database. So instead of directly sending the event, what you do is you begin your transaction, update user, store in database your intention to send something to the Kafka, and then commit transaction. And then you have some kind of a, let's say, watcher or event publisher who constantly checks the database, is there is new events, is there is new events, is there is new events, and pretty much only then sending it to Kafka. This is exactly what will give you at least once delivery. But, okay, example. So let's say this is really my favorite one. It's really simple, but I think actually either Rohlik or Volt or someone did a mistake in this architecture and someone was receiving like their noodles twice or something like that. This is pretty much the reason why it happened. You have your payment service, you have your order service. And order must be dispatched only if, and only if, payment was successful. And you have two separate services. Okay, so now we are smart, and we apply an outboxing pattern. So we having like here payment service who logs everything in its database, and like constantly rechecking if there is new events in outboxing table, and then pushes them to the Kafka, and the opposite side gonna receive it. In the same manner on the opposite side. But there is another hydra there, and this is because by definition this is at least once delivery. Even though you guarantee that your message is going to be received, you did not guarantee that it's going to be received once. You can still have like a multiple message by the design of a system who can be duplicated. And in this manner, you're at risk pretty much that the user paid once, but you send an order twice. Kind of not good for the business. Well, the solution is kind of easy. Again, doesn't work much attention. Usually, we have some kind of idempotency. This is why idempotency is actually really important in the microservices world. Who don't know what is idempotency? No one? Come on, guys. Yay! Pretty much, what it does mean is that regardless of how much the same message you're going to be sending, the system going to be reacting the same manner. The classical operation is like fetch or get. Whatever, doesn't matter how much you call the get for the same ID, you're going to get the same result. But there is a problem with write operations, or operations that mutate state of your database. Well, for this matter, you can use a simple deduplication mechanism. Really classical of that is that every message that you send to another services has a unique hash that is based on this message. And other services have a database, or a blacklist pretty much, of all the hashes that it received. You can clean it eventually, for sure, but it's always comparing the hash of a message that it's received and checking if it was not received previously. And in this manner, you can actually guarantee idempotency of mutated operation. And this pretty much, I'm on targeting and looking at Vít. Hey man, you're going to be talking about that. It's about sagas. Because sagas is more about orchestration between the microservices, but outbox is essential part who only will ensure that your communication is 100% reliable, assuming you need it. So yeah, man, please save me. I think summary, this is my like favorite tweet about like distributed systems. I don't know, who saw it previously? Wow, awesome. Well, it's hard to read, but like there is only two hard problems in distributed system. Exactly once delivery, guarantee order of message, and exactly once delivery. That's pretty much your daily bread and butter with all the distributed systems you have. So, what we should make peace when we transition to like more distributed system is to make peace with the fact that we don't have exactly once delivery. It's just simply not possible. Even like by mathematical definition, a network was not designed like this. Distributed system has no common knowledge, and there is pretty much no way how you can ensure consistent ACID-like common state between distributed nodes that communicates over network. What you should do about it? Well, the same as you do in life. If you cannot change something, just accept it and make peace with that. And what you need to do is to mitigate the risk to acceptable degree. And again, there is no silver bullet, and there is no single solution that's applicable all the time. It always relates to the business context. You have some easy operations, just like send notification. Yeah, come on, just use like a REST API and forget about it. You have a payment and order service. When in that manner, you need to go all the bells and whistles and apply the full pattern to ensure that your business will not send a new PlayStation twice, you know, or something like that. That's all, guys. Thank you all.
Hey, Nikolai, thanks so much. I'm looking at the Slido, and there's one question, and between me asking the question, feel free to think about your own question. I can kind of pass the mic to the to the audience, so you don't have to type it in Slido. For sure, there will be some more questions. But hey, Nick, how do you synchronize writes to 2 DBs? Yes, imagine you have like, I don't know, some legacy DB and a new DB. You know, you're migrating from monolith to microservices, and you need basically to write the information into 2 DBs.
You don't. Just don't do that. Well, seriously, like in this manner, this is exactly where actually with sagas will be more useful in this. You need to orchestrate this operation. This is normal distributed transaction. Just like if you have 2 microservices with 2 databases, or simply 2 databases, just pretty much the same thing. You don't have transactional context. So you need your own custom orchestration to compensate for the potential failure of the transaction.
Okay, thank you. And here a new question appeared, and that is, isn't outbox with deduplication equal to exactly once delivery?
Kinda, I guess. This is actually like the final goal, but I would assume we will call exactly once delivery if it was working by design on a network. Otherwise, we need to compensate for that and create some kind of a machinery around it.
So it's like exactly once delivery from when you get it from Wish?
From what?
Like when you order it from Wish?
Yeah, exactly,
okay.
This one.
Okay, cool. So are there any questions from the audience?
Yeah, hello, thank you. My question is, as far as I know, TCP protocol guarantees the order of data, the delivery of data, and so on. And what is our problem here? Like, why we just cannot repeat what the TCP protocol guarantees?
Oh, that's a really good question. Well, TCP protocol guarantees order of one message, one concrete message. And it does guarantee that the sub-packages of this message will bring in order. However, what TCP protocol is not guarantee is that you will get a response. If you will send a request, and this is like a common like misconception, and even HTTP works this way, nothing guarantees that you're gonna get any 200, 500, or anything like that, like on the way back. Good?
Thank you for amazing presentation, Nikolai. I wish we implemented Outbox earlier, but we have it already. I have one question. If you have some experience with implementing the watchers of the Outbox table you talked about, because we had to implement it with Postgres and AWS Lambdas, and we had,
Answering your question, actually I had a pieces of code prepared. I'm trying. How should I do this? View. I don't know. Wait a sec. Yeah, perfect. Well, to be honest, you can implement it, and there is 2 ways how you can implement watchers. And there is one called like application-based, and the second is pretty much infrastructure-based. And it really depends on a scenario. Like a lot of the time, application-based is actually way easier and way cheaper. And what it is actually is just a cron job who goes through all the tables in the outbox in table and just tries and tries and tries and tries. And pretty much just you need just one thread. And it pretty much works every single time. The only problem, you have to do it yourself. There is another one, and it's called transaction log tailing. telling, I guess. And you have a transaction log, and you're watching the transaction log, what's happening to the database. It gives you like way more robustness, and there is usually a specialized software for that, like Debezium. The only problem with that, especially with the cloud services, you not always have access to the transactional log. It pretty much implies that rather implement it on application level.
Yeah, we ended up using the application level because I think we didn't have access to the logs, and we used two approaches. Like one of them is cron, like 5 minutes, I think, or 1 minute, and the other one that the source code, the first code, like asynchronously executed the consumer, the watcher, after he finished completing the code.
Yeah, that also can be. Even actually database triggers could be a valid strategy here. But like for our case, we implemented as easy as just a for cycle with a cron job. That's pretty much it.
Okay, thank you very much.
I have one question from Slido, and then we will take one last question from the audience if there is any, and that is, Nikolai, is there anything we can trust in distributed systems?
Only your skills.
Yeah, that's nice. Pretty gloom, but nice. Any more questions from the audience?
Thank you, guys.
Okay, so thanks, Nikolai. Thanks for an amazing talk. And we will go straight to the next talk, because we have this kind of unique combo where the next speaker continues and expands on the topic of the first speaker. So please welcome Vít Herain from Investown, our client, where they are using distributed architecture for processing investments into real estate. And Vít Herain is one of the guys that built a system that processed over 1 billion Czech crowns in investment money. So very nice, very nice. Vít is interested in domain-driven design, AWS, and all the stuff microservice. So Vít, please take it away.
Hello, everyone. Thank you. I will talk about Saga pattern, as Nikolai already said. So why would you use it? It's a way how to solve complex processes, or how to implement complex processes that involve various contexts, or maybe microservices. I will refer to it as microservices for short. So when you implement some complex process that needs to, where various microservices need to participate in, you need something to solve problems, as Nikolai introduced. So Saga pattern is one of the ways how to solve it. Something quickly about me. I'm about 10 years in IT. I'm working currently in Investown, and I was for 4 years full stack developer at Zanki before. And the rest is was already said. So let's jump straight into it. Why would you need Saga? But maybe the better question would be, why not use distributed transaction, which is counterpart of the Saga principle? You of course could use distributed transaction. This is not something wrong, but nowadays. There is often lack of support with all various technologies you often use. For example, Apache Kafka or something like that, or NoSQL databases often don't support distributed transaction. So it is not an option for you in this situation. Another problem with distributed transaction is reduced availability. Let's take a scenario where you have two microservices, service A and service B. They both have their own availabilities, as you see. And when your client raises some request to your service A, and service A needs to handle or call service B in order to handle properly this user request. This is similar to distributed transaction, because all participants need to be when when the transaction is running. So what will happen then? Client calls and service A calls service B synchronously. Then overall availability is reduced and is much lower than the original one which those services have. The third reason to not use distributed transaction is that when we saw CAP theorem, as Nikolai introduced, nowadays availability is often preferred to strong consistency. So again, distributed transaction is not an option here because it is here in order to ensure strong consistency mainly. So what is Saga? It is basically, it is nothing complicated at first. It is basically sequence of local transactions. The word transaction is important here because transaction means that it is some local transaction, for example, here in order service, and this transaction is in a manner of relation databases. What are traits of database transaction? It is asset. It is atomic. Thank you. Atomic, consistent, isolated. It's important and durable. And we will talk about it later. But this is important thing. When you use Saga, changes that you make in the Saga or in a process are eventually consistent. They are not right at once committed to the database in every participant, but they are eventually consistent. This has major outcomes and consequences. My recommendation, or maybe general idea, is that it is better to run it asynchronously from client's point of view. So maybe it is not a good idea to execute some Saga that spans multiple microservices, and you don't want the client to wait for a response synchronously. I will show later how to solve such an issue. So when you implement Saga, there are two main approaches how to coordinate the logic that must be somewhere implemented, how to decide what's the next step. The first approach is choreography. It's an approach that serves the best for the simplest scenarios where Saga have, I don't know, 2 steps maybe. And the main trait of this approach is that every participant does its work and emits some event. This event is handled by another participant, and this participant must know how to decide upon this event and execute its own logic. So the outcome is that every participant knows about other participants, and it introduces some coupling between those services or participants. The other approach, which is recommended for more complex scenarios, is orchestration based. And in this approach, there is always some centralized point or entity when you can see how the Saga's logic is implemented, and it's implemented in one place. It could be, for example, Java class or AWS step function instance, or how to say, or there are many other options. But basically, you can find some central place where to find how this logic works. Okay, so we chose orchestration-based Sagas, and we will look into deeper now. Here you can see some scenario where when our client wants to invest in some real estate property, let's say, and he does it by issuing some request or command, for example, through REST API or through GraphQL API, and wants to place an order. So, okay, he issues this request and places an order, this service, what it does, it creates an order with status equal to placed, let's say, and then it creates the instance or stars instance of Saga Orchestrator and returns a response to the user, and the rest is handled asynchronously from the client's point of view. So I made another image which views the same scenario. As you can see, the user wants to place an order in order service. This service creates order, creates Saga Orchestrator, and it will handle the rest. And the order service then return response to the client. And client does not know what was the final result of the order, of course. But Saga Orchestrator probably finishes its work sometimes in the future. So when it will happen, you can say you can, for example, send a notification to the user, or there are other options. Of course, you can use some optimistic updates, but maybe it's not for every situation. Or the notifications could be of various kinds, for example, emails, push notifications, and something like that, in order to client inform about completion of the task he tried to make. Okay, as you might have already thought about, there are of course some issues with this approach because of eventual thing I spoke about. And when you have distributed transaction or maybe local transactions in microservices, there is always possibility that something goes wrong, and you can always roll back the database transaction in relation database manner. So what's the counterpart of this approach in Sagas? You must implement some rollback, but you must implement it by yourself. So in our scenario, which is going more complex now, when our user, for example, wants to place an order and invest in some project, and we find out in the third step that the user has not enough money, so what do we do next? We must handle it in some way. So the possibility here is, or a way how to do it in Sagas is to implement so-called compensating transactions in every participant that's needed. For example, in investment service, you need to implement local transaction that is able to revert this investment that was already made and cannot be reverted in the same manner as in database AC transaction. The last step is similar. You can, for example, roll back this step that placed an order, for example, like that you mark this order as unsuccessful by changing state from placed to unsuccessful. And the user will be let known using some other notification, for example, let's say by email or push notification. Another problem that is present with Saga pattern is the lack of isolation. As I mentioned, that local transactions or in general distributed transactions have very significant trait, and it is isolation because it is ACID. Sagas don't have isolation. Because if you think about it, what will happen if, for example, we have also some other Saga, let's call it cancel investment, in order for client to be able to withdraw from an investment or cancel it later when he decided to get back his money. What will happen if it's executed concurrently with the original Saga that placed an order? There are anomalies that can occur here. For example, lost updates. What will happen when we execute this cancel investment Saga, and this Saga simply changes status of an order from placed to cancelled. How do we solve issues that might follow? Dirty reads, fuzzy, non-repeatable reads, those anomalies can occur. I will show you a proper resource to study it in a more detail and how to solve it. Basically, those problems and anomalies can be solved using what is called countermeasures. There are various countermeasures. I think there are 5 or 6 of them, but I will speak about only about two of them, which is semantic lock. I will show it on the diagram, and pessimistic view. Pessimistic view is example of countermeasure when it is sufficient sometimes to reorder steps of interfering sagas that can sometimes run concurrently, and it can be sufficient solution. But semantic lock is quite simple, and we can look into it right now. So when our user places an order and order status is set to placed, as I said, and then we want to invest in project, and the steps is executing right now, and then our user decides to cancel the investment in the same time the invest in project step is being executed. We can simply check in this step what is the status of the order. We see that if the status is placed right now, it means that the flow of the invest saga has not been yet finished. So the proper strategy could be that this cancel investment saga will fail and return some maybe understandable response to the user that he should try it a little later, or maybe here we can poll and try it again. For example, there are various strategies, but the message is that you should check the status of the order and not set it straight away to cancel, for example, because you would have there would have be lost update anomaly. So this is very simple example of countermeasure. To summary it, let's see some best practices I find important when you want to implement some sagas in practice. I would say that it's good to not start with the most complicated scenarios at first, and do not complicate it with handling various error conditions. You know, what is important when you have some error conditions that might occur. For example, here, when you want to charge customer, there is a business rule that can be violated, and with some I don't know, error or exception, you can find out that this user has not enough money to complete it. So you handle with it. But if you make it too complex from the start, you would maybe handle various technical errors that might always occur, and I would recommend not make it overly complex from the start. Implement some alerting, monitoring around the saga, and be able to handle it later in some manual way when some technical unexpected error occurs. When you implement saga practically, there is always good practice to when there is some technical errors, as I mentioned, it's good to use retries. And when you use AWS step function to implement sagas, this is very simple. You can write retry clause and it is handled. But when you use messaging, for example, it is kind of how to say, out-of-the-box present, because when you use some, I don't know, queue, the queue probably retries the handler of the event, and this is connected or linked with the theory that Nikolai introduced. Because when you have retry, there is, let's say, at least once derivative of the message or the request. What is the necessity that is an outcome? You must handle you must handle idempotency in your Saga participants, because if you don't do that, there is a problem with duplication of messages, and probably you could charge your customer twice or something like that. Make it asynchronous from client point of view. As I mentioned and shown on the image, it is better to send some notification to the client when the job is done, because you don't know if every participant of the Saga is always available. You can be sure, so leave it for later to notify client about completion of the request. Transactional outbox is also the necessity of the Saga pattern. Let's say that in choreography-based approach is necessary the most, because when participants communicate using messages, then if you lose some message, for example, it means that the Saga won't finish. And as I already said, implement monitoring from the every Saga to be able to resolve some production issues that might occur. As I promised, there is a good resource, in my own opinion. If you study it, chapter 4 from this wonderful book, there is a theory about Sagas in general, but also there is lack of isolation deeply discussed, and also the countermeasures I mentioned. So take a look at it. That's all.
Thank you. Thank you. Okay. Wow. Nice. Thank you, Vít, for the awesome talk. I have the first question will be from me, and that's, how do you debug this stuff?
Yeah, we use in Investown AWS step function, and there is pretty much a good possibility to look into it, how it was executed. There are logs, there are visual responses, how various steps were executed, so it's a good option. When you implement it, for example, using messaging, as I mentioned, I think you often do it using some framework. So I hope the frameworks offer some possibilities how to debug it properly.
Mm-hmm. Okay. Another question is from Slido, and that's, how many developers work on Investown backend?
I guess 4 or 3, I don't know, nowadays.
And then the devil advocate's question then would be, why would you have a microservices at all then?
Yeah, I don't know, but we have a serverless approach. So basically, there are problems when you have everything in one place with deployments and other things. So microservice approach makes sense for us.
Yeah.
Because Lambdas are grouped.
It will
around
definitely
microservices.
Yeah, it will definitely help you scale, right? Like when it will be teams of 40, 50, 100 developers. I think that yeah. Sorry, that was a low ball from me. Okay. Another question is. Oh no, it's a sharing of best practice. Use deadlines so you can expire long-running sagas. So.
Yeah, good point. Of course, this is something that is maybe out of the box present in AWS Step Function. It's right that we do it always in every Saga. Yeah, good point.
Mm-hmm. Cool. Any questions from the audience?
Thank you, Vít, for the talk. You showed it that it's not so easy and simple to implement it right, and you talk a little bit how you debug it. Can you describe how you test it? Because during the whole transaction, so many things can go wrong. And is there any tool to simulate all some kind of weird possibilities, or just basically how you do it?
Yeah, as I mentioned, we use AWS Lambda, and we are a serverless company, so it has some consequences. And when you asked about it, we are able to test. We are able to write unit tests for Saga definitions. When I write some definition using AWS Step Functions, I am able to use some Docker container from AWS and run it in our development environment or in GitLab runner, and I'm able to write scenarios and I can mock some lambdas, what they respond and something like that. It is even able to call lambdas, real lambdas in some environment that are deployed, but we don't do it like that.
Okay, yeah, I see. Thank you.
Yeah, thanks again. And my question is, do I understand correctly what due to Saga provides only eventual consistency, then we still don't have any strict guarantees of, let's say, what everything will be fine. And the skill of the programmer is still the weakest point here.
I'm sorry, I didn't understand properly.
So this approach doesn't guarantee the consistency of the data, right? So the skill of the programmer is still the weakest point here. Like, okay, whatever reliable the services are, if I don't know how to use them, I will use them incorrectly. Then why do we use Saga? What it will, how may it help to, let's say, average programmer?
I don't know if I understood, but maybe you mean that distributed transactions are better because of the consistency, or
maybe how skilled programmers do you need for this? Because it sounds complicated. Or like, do you have problem with your teams to kind of understand what's going on, or like when you onboard new people into this thing, like how long does it take them to be productive in this system?
I think we don't have big problems with it. We are able to explain it. Maybe there are scenarios where it's complex, but there are no other options for us, so we must cope with it.
I have to confess, we've onboarded some of our guys into their system, and they were pretty quick to pick it up. So I don't think like with AWS Step Functions, it's actually like the orchestration is really good. So you get like a lot of visibility and a lot of transparency in how it goes. So I think that it's all about tooling you use, because, for example, we have experience that if you use very bad tooling for this whole thing, it's super messy. If you use very good tooling for this thing, it can actually make the business processes a lot easier to understand, because you kind of can step through it and see what happens, in the orders, in the wallet, and so on. Okay. I will look into Slido. There's no more questions. So any more questions from the audience? Roman.
Yeah, thank you for the talk. It was great. I was wondering, like, how is it with testing? Do you test it using like, end-to-end tests, because it's obviously that complex, or can you test it? The orchestrator needs to be tested somehow, which I assume you can then fix that problem with the skill of the developer, right? Like,
Yeah, as I already said, we are able to test it using Docker container, and which is execution environment you have in on local environment, let's say, or in test environment, and you are able to write unit test. So when some developer is new for us, he can, for example, get some task to implement new step function, and he can start with tests as TDD development offers.
Okay, thanks, Vít, for the amazing talk on a very, very complex topic. That's awesome. So give a clap for Vít. Nice. And now we will have a break. The break will last 30 minutes. We will see each other at 19:30. Where don't go everywhere, because Roman will tell you about the hottest and greatest thing since sliced bread, and the way how we could kind of avoid some of those problems we are talking about here, and that's the future of writing distributed applications. So stay here for that. We will meet at 19:30, and some stuff to keep you occupied. There's a lot of food, there's beer, there's other things that kind of you can drink, and it's not a beer. And also there a quiz you can take. It's I think it's there at the beer, and you can take it, and then if you go to, and also it's here on that pillar, and if you take it and you complete it and you go to Anička, and you will be one of the first of the 5 people that completes it, you will get much way cooler hat than I have, but it is this kind of a hat. So do it. Okay, thanks for your attention. See you in 30 minutes. Halo, 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 halo. Jo, 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 jo. Raz, dva, raz, 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 dva, tři. Tak, milí hosté. Oh, we are running this in English, right? I forgot. Yeah, right? Okay, English. Cool. So, dear guests, please take the seat. We will start just in a minute. I am awaiting go from our streaming engineer. We have a go. Okay, cool. So, I hope you enjoyed the break. And now, the next speaker is Roman Schejbal. He's a consultant in the fintech industry, but also a full stack developer that went through many projects, and he just fall in love with Wasm. Is that right? Yeah, and Rust, but you know, that's niche. But anyway, now Roman will be speaking about the future of distributed architecture. So, give a clap to Roman Schejbal.
Is this working? Oh, okay. Hello, everyone. So, some of you may know me. I'm a little bit into innovative tech and tech in general, but if not, today I want to talk about what the future looks like for distributed systems. What I want from you is to actually not think about it as from like a tech perspective, but more as like a paradigm shift, maybe, or we'll see. As soon as I figured that this meetup is called the Challenges of Backend Architecture, I immediately imagined I have to show you this slide, because I think this is the challenges of distributed systems. This is the CNCF landscape, Cloud Native Computing Foundation, where we have a list of gazillion technologies that we use to, you know, make our lives more bearable while building these systems, right? Anyway, something about me. I'm a full stack engineer. I've been learning computers for more than 15 years, actually more than I'm willing to admit. If it was up to me, I should be much further, but whatever. I just got back from Rust Nation conference in the UK this weekend. It was great, and some of the things that I'll be talking about here were presented there as well. So I can recommend watching the talks when they get public. Anyway, I'm currently on sabbatical. It's been 4 months. I can recommend for anyone. And I love tech. All good? So this is the agenda. I want to quickly talk about 4 things. Well, yeah, sort of 4. About systems, then distributed systems, networking, how we do those. We've already have 2 great talks on that topic, so I'll just you know, fly through. And if the demo gods permit, I'll have a demo. We'll see. So the first thing I want to talk about is what is boilerplate code. It's going to be a little bit chaotic until we put everything together in the demo, and I just chosen these 4 things. When one of them is boilerplate code, you'll see why. So this is the Wikipedia. Well, in 2023, we should have probably asked just like the ChatGPT, I just realized, but here's the Wikipedia definition of boilerplate code. So boilerplate code is basically the code that you have to write until before or alongside with writing your business logic, right? This is like the simplest definition. Sometimes we call it also accidental versus essential complexity. In one of my favorite papers, Out of the Tar Pit, this is distinguished as essential complexity is the nature of the beast you're trying to tame, which is basically the business logic you have to write, and the accidental complexity is like, you know, we need to have retries between distributed systems and whatnot. So, the distinction that I'll go with is, I'll go with the functional versus non-functional requirements. But we are talking about the same stuff. On functional, you can think of like that's the what of what you need to do, and the non-functional requirement is like how you're gonna do it. Yeah, so that comes back to the essential versus. It's a little bit different mapping, but we're talking about similar stuff. So again, this is the slide for this. And what I wanted to say, we have actually gone quite long distances to make these divisions in our systems, right? You know that you're using like hexagonal architecture or like onion architecture in your applications in order to separate those concerns. And so you don't want to be, your business logic don't want to know that on the back end you're actually using Postgres database, for example, right? So you have like abstractions, adapters, and whatnot. We call these anti-corruption layers that I had on the previous slide, but those are basically the facades, adapters, all the stuff that we had to build, so we could, you know what I'm talking about, right? So I have an example here, just a quick one. This is Karen. She wants to build an app, and this was supposed to be a talk about Rust, but I changed it then. So in particular, Karen wants to build a dating app, and she wants it to be stable and fast, so she builds it in Rust. That's supposed to rhyme, but whatever. She's also willing to pay the upfront cost of compilation times of Rust for those that, think that Rust is slow in compilation time. Obviously, for reasons, good reasons, by the way. And it's been the, most lovable language for 7 years, so why not? I actually came across this chart, which I think is super cool when it comes to Rust. You can think of, I think it's actually true, right? Because I don't know does anyone know Rust here? Right, okay. So Rust is quite difficult because it adds you like 2 more features to the language, which is like ownership and lifetimes. And now you have to think about those while coding your application. And you just figure that at some point in the future, right? And then your productivity just skyrockets because you start to use all those features of the language, which is, some of them is like traits, and they compose really well. You create like an ergonomy, I call it. We can take a look at that at some point in the future. So she starts by building a web server, right? She needs to set it up, so she says like, okay, I'm gonna use ActX Web, which is one of the frameworks for Rust. And she's gonna say it's gonna run on port 8080, whatever. And then she's gonna write some business logic, AKA routes, whatever it's doing, I don't care. But this is the business logic that she's writing, right? Sort of. Then she figures I'm gonna need to send notifications to users, so she'll have to set up a mail server, or like this could be a push notification to mobile, whatever. Again, some boilerplate code, and then she can actually use it as a service inside that business logic, right? This is how we used to write our codes. And this is like a quick summary of what we just gone through. You can see that every business logic has its non-functional requirement along with it, and you may think, well, this is not a big deal. Well, I've been building applications since, I don't know, and I've built probably too many, so I know this hurts in every new project. This hurts, right? If you set it up once, then you may think, okay, it's not a big deal. But then again, you can think of this. Other reason this is not great, and I'll get to it, but is that if there is a bug in that framework, it's connected with our business logic. We shipped it as a monolith, right? So if we need to bug fix that framework or like update it to newer version, we have to redeploy whole our application, right? I'll get to this in the demo and you'll see what I mean. But this list goes on, right? And this is like the functional requirements I came up with for that dating app. And you can see that the non-functional requirements list is the list is basically skewed to the right, and you can tell it's all important stuff, right? Now I want to talk about a shipping model comparison. Yeah, now we know what boilerplate code is, right? So now we talk about how we ship applications to the cloud, or how we used to do it in the past. So in the past, we used to ship whole virtual images, to virtual machines. You can see in the red circle always, you'll see like what we are actually shipping when it's running in the cloud. Virtual machine images take minutes to spin up, so it takes, well, we've been there. Who has been there? I've been there. Cool. Now we ship containers, right? Much better. Whoa, brilliant. So they spin up in seconds. That's like 60 times improvement. But can we do better? Yes, we can. Tomorrow we'll be shipping WASM modules, and if I say tomorrow, we'll actually do it today. Whatever. WASM modules spin up in milliseconds. Again, another improvement there. And I'm not even talking about the sizes of these things, right? You can think of these gigabytes, megabytes, maybe 100 of megabytes, and then over there we have, I don't know, 10th of megabytes top. And there are actually platforms being built on top of this already. One of them is Fermion. You can take a look at it. It's really interesting. They have like a CLI that you can use and like ship your application to production in minutes, really. Like, the question is like, can we do better? Yes, we can. We can, if you read the title, in a week we'll be shipping actors, but we'll actually do it today. I'm not gonna ship it to production though, so it's a bit different. We could, but there's no time for this though. But here we have actors, like who's familiar with like the Elixir or Erlang ecosystem? They have like actors, and it's basically built on top of actors that communicate with to each other, and their network mesh is abstracted away. So that's like, here we were still building applications that have the functional and non-functional requirements together as a monolith. Here we have it separate. We have like functional requirement, logic, and capability provider, as we call it. And there again are platforms being built on top of this. This is an open source initiative that's called wasmCloud. It's basically a bunch of clever guys that went forward, and probably too fast, because now there is something called web components in the WebAssembly initiative, where they are actually trying to standardize these things. But these guys went ahead, implemented their own platform or like open source tools on top of similar patterns, but not standardized yet. So this is like cutting edge. If you want to use it, you'll be bleeding. Anyway. So as I mentioned, wasmCloud is a technology, I would say, and there's a platform being built on top of wasmCloud tools that's called Cosmonic. And you even get this like drag and drop. You'll see a simpler version of this in the demo. Now I want to talk about capability providers, like what those are. But you probably have an idea already, right? So capability providers, this is I want to talk about like design by contract. We are doing this where we talk service to service, right? It sort of needs to have like an API that understands to the other one, and vice versa. What's important here to realize is that when we talk about these capability providers, don't forget about the thing I mentioned at the beginning, which is we don't ship them alongside with our code. They're not part of the actor. They are separate things, right? And we use them to decouple the non-functional requirements. We have an actor and a capability provider, and then we have like something called parametric linking between them. Parametric linking basically means you're gonna talk to this service, and with these you can add like additional parameters, like for example, credentials for. You'll see in the demo again. It'll be easier than trying to explain it. And then networking, that's an important part of any distributed systems, right? So nowadays, what is it, like what makes a distributed system? It's like computers talking to one another. again, it's from Wikipedia. And what I'm talking about now is like, we're trying to separate these non-functional requirements from functional requirements. And it's not my idea, obviously. Dapper is a thing. Does anyone know Dapper here? Right, Dapper is supposed to abstract this away using sidecars in Kubernetes, right? So they're doing like similar thing, and they connected to a language even, mostly supporting C# as far as I know. But I have no experience with this. But it's doing the, this is their title from the website. So basically, their approach is similar, but different, but trying to in the end trying to solve the same issue. And how we talk about when services talk to each other, we have like usually we have like obviously there are multiple options, but we usually have two. And one of them is service mesh, where we have something like Istio that abstracts a communication between services. It is called the synchronous calls, right? It abstracts away retries, encryption, load balancing, service discovery. What have you. There are some cool service meshes like Envoy that actually support plugins written in WASM. So you can abstract away even further things that you can think of, for example, A/B testing or blue-green deployments, whatever you call it. And then the other approach is using event mesh, right? We all know Kafka and what it is for. I think this is called event mesh, I'm not sure. Don't quote me. This is better for like scalability, fault tolerance, reliable messaging. So just use the right tool for the job. WASM, however, uses, or like wasmCloud actually, wasmCloud is a concrete implementation of those ideas. So they use, what is this doing here? Sorry. They use something called Lattice. And Lattice is a self-forming, self-healing mesh network that's built on top of NATS. And NATS is a very interesting technology. Does anyone know NATS? Wow, okay. NATS is basically lightweight Kafka. You don't need Zookeeper. You don't need two instances. You can just run it. It has leaf nodes, but it's basically doing the same thing. And it can even do stuff like, we talked about exactly once delivery. What you actually want is exactly once processing. And NATS can do that using something called their feature Jetstream. But it's basically, I feel like people tend to reach for NATS instead of Kafka these days, unless they're, most of their services are written in Java. So, make the choice, whatever. Anyway, so this is called Lattice in the wasmCloud. They call it like the mesh network that abstracts away these things. This is an illustration how it looks like. NATS provides a global service called NGS, which is free, and you could obviously a paid service as well. But NATS is intelligent enough that if you just, let's say you have multiple clusters in different countries, or even because we are talking WASM modules, we can abstract these things like cloud vendor lock-in. If you are in some industry that, for example, healthcare, they will regulate you by saying you have to be in multiple clouds. How do you now you have to deal with zillions of other shit. Ooh, pardon. And but yeah, so let's say you have multiple clouds and NATS can talk to one another and connect to each other, encrypt everything. It's actually very cool. If there's one technology that you should look into, it's definitely NATS after this talk. So NATS in wasmCloud uses in many ways. It does the request reply messaging, as I mentioned, Jetstream to persist link definitions, the parametric linking between actors and capability providers. And there will be like an application deployment manager, which is called VADM. And you can think of it as the, it's like the kubectl thing. And now we'll look at the demo. If demo gods permit. How am I doing on time? All good? Right. So here I have some Rust code that's compiled to WASM because Rust has the best support for WASM at the moment, and I think it's going to stay like that anyway. Oh, you don't see it. Sorry. Hop. And is it good now? Can you see it? Cool. So here we can see that we are importing some interfaces. Again, those are just interfaces. Like those are the contracts that we talk to capability providers eventually. We have like a blob store contract and HTTP request response server. So because like our application is a very simple one. What it's gonna do, this is basically the name of our application, and this we have the implementation. And all you see here, apart from this hairy stuff at the top, is basically, so this is like, it's a bit hairy still, you know, this is cutting edge, but it's gonna get shrunk even more. This is the boilerplate code, I would call it. And then we have business logic in the handle request function. So you can tell, you can look at. So we take, we parse the query string, we take the name query part from it, and we save it to the text variable. And we use the blob store because we want to create a folder called Applifting, and we want to upload the file into that folder. Yeah, with the name is Uplifting. Wait, the text, the object ID. That's the name of the file. That's the text as well, and the contents is the text again. Like I could probably think of more complex application, but yeah, we can abstract these into functions and whatever. You know, this is just early stages, and then we return OK HTTP response that hello whatever. And if there is no value, there will be world. So if I run this, let me run this. Wait, I need to start. Now I need to start the runtime that's gonna host our application. Right. Here. So this is the wasmCloud runtime. You can have multiple hosts connected together that talk to each other over the NATs that we talked about. And now here we have, there's like host info. But here we want to have our actor, right? So I have compiled it before, just to minimize the chance of failure. So now we have actors running. It's actually not running. It's actually like a serverless function. It's only invoked when there's a whatever provider triggering it. We're gonna need a HTTP server because we need to handle requests. So that's our HTTP server running, almost awaiting. And now we need our blob store capability provider, which I have here. And now we need to parametric linking to link those together. And so server, and it's gonna fulfill this contract. And then we have actor and file system blob store that's gonna fulfill this contract. So now it should be running at port 8000. And it is, although you can't really see it, I guess. Anyway, that's not the end of the demo. Now I'm gonna show you something cool. So we have a file system blob store, and I'm gonna add a new provider that's also implementing that blob store interface that we talk about. But its implementation talks to the S3 bucket. Everyone knows what S3 bucket is, right? It's the AWS storage system. And now we can just define a new link. I didn't show you that it's actually running, working actually. So we should see here in the previous request that we had a, well, let me do it again. So I'm gonna add query uplift oh wait, it's supposed to be name, right? Thank you. So we say hello uplift. Here we should see that create direction has been, run here. Let me just quickly, what is it? MDI? And uplifting, and then we should have uplift there. There it is, yeah. So you can see it's working. Now I'm gonna change the capability provider. I mean, I've added it already, but I haven't connected it to our actor, right? So I just need to define a new connection here. We have blob store. Now we need to give it things like credentials, like AWS secret IDs and stuff. Now if we refresh, don't know if it did anything. We'll see. This is the S3 bucket. Wait. There we go. Uplift. 1955. So as you can see, we just hot swapped a capability provider without actually turning off our actor. So, whenever you need to do that, and you can write your own capability providers and whatnot. And those actors also run anywhere you want. Back to the slideshow. No, there. So this is what we just did. We have our actor, and then we hot swap the connection to capability provider. This is a huge thing, right? If we had to update our HTTP server, which is down here, for a newer version or a completely different one, we could just do that without any downtime or actually redeploying our actors. This is a huge thing, really, because even the founder or co-founder of Docker once tweeted that if we had wasm plus this WASI, 2008, we wouldn't have to need that to create Docker. But yeah, it doesn't mean it's going to replace it. It's actually catching up, so you can now ship not just Docker containers to the hub, to Docker Hub, but also WASM modules. Another thing is what we just looked at is that's why I said at the beginning, think of it as a paradigm shift or like a change in the way we build things, where this is actually happening on the front-end side of things as well. There was a great talk at the Rust Nation UK conference about this, looking at how we can use this with iOS, Android, desktop, these front-end applications, where we write our business logic once, and then there's one caveat or something to realize, and that is that the UI is actually a side effect as well. We need to think about it that way. Everything is a side effect. See it as a user interaction event, and then we have our core that's actually tested. That's the pure logic that can be tested without any side effects in it. Highly recommend watching that talk. It's really goes even deeper than what I just did. What we talked about is here, and also what we could talk about. This is all progressing quite fast, although probably not fast enough. We have this WASI WebAssembly system interface, which is for the input-output, and that's being standardized around these web components these days. So I guess it's gonna take a few months, years, maybe a year. And that's it for me. Thank you very much.
Hey, ho ho ho. Do you hear me? Okay. So Roman, thanks so much. That was very cutting edge. I'm bleeding all over the place. So my first question is, do you think it's production ready? Can we ship it? Can we run, for example, Investown in Rust and wasm in wasmCloud?
I would say it depends on the context, right? No, seriously. If you are one of those that don't mind rewriting your apps and stuff every other. Yeah, the interface is going to change, but the concept probably won't.
So if you should put a timeline on it, when we all be writing WASM modules and deploying actors?
That's another, like, it depends, you know what I'm going to answer. Like, I don't know, you know, everyone is coding here in Kotlin, Golang, whatever. Those require garbage collection. That's something that people from WASM are working on. Although, just figured recently that the garbage collection they are implementing is not going to work for Golang. But they can ship their own garbage collection, which is going to make their WASM modules huge. But yeah, whatever. I highly recommend learning Rust because it's been I've coded in few languages already, quite a few actually, and Rust has been joyful, and it actually brought the joy back to me about coding again.
Okay, nice. Yeah, I've programmed in Rust too, and like it has steep learning curve, but it was fun.
It's definitely worth it.
Let's say it was fun.
It's worth it. Yeah.
Okay, so now the questions from Slido. How the capability provider knows how to replicate all the data when you switch from the local blob store to S3. Can you do it with like MySQL to Postgres? Because I've noticed that there was like there were actually 2 entries and you refreshed only once.
Yeah, no, it doesn't. It doesn't replicate the data. That's a misunderstanding. It doesn't do it. Like obviously, you just connect it to a completely different service. Because I then refreshed and it would save it again back to. It's more about. Yeah, this is really a stupid example. I should probably come up with a better one.
Okay, so that's basically like the hello world was a kind of a glitch there on S3 bucket.
Oh, that's triggered by the favicon request.
Oh, the favicon request.
Yeah, it makes another request to the server, so it's handled by the same. Yeah, that tricked me as well when I was implementing. Like this request happened twice, and once without the query on a part. So whatever.
So it's the favicon.
There's no routing abstraction yet, but that's just
okay, cool,
cutting edge stuff.
Cool. Any questions from the audience? Okay, this gentleman wants to be cut by the cutting edge.
Yeah. First of all, thank you very much. And you managed to trick me because every time I hear without boilerplate, I hear also Kotlin. So yeah, nice one. But well, for such a sweet summer child writing in Kotlin as me, Rust is considered as quite ruthless. So do you understand what everything what can be compiled to WebAssembly, like the same Kotlin through GraalVM, can be also run using this one?
I don't think so, because even this is not standardized. So I don't imagine that GraalVM would make it compatible with. If you mean like the WASI stuff.
Yeah. So. Do you have the full support of WebAssembly or just some limited one?
Pardon, say again?
I just don't understand what do you mean by this. So do you have the full support of WebAssembly as a, let's say, as a standard? Or
oh yeah, there is a full support because the runtime isn't like written from scratch. It's more about it needs to conform these interfaces that we looked at in the demo, which is like, up here. So you could eventually make it work, I imagine, although I've heard that there are some issues with WebAssembly and GraalVM. But yeah, I'm not into Java much, or JVM.
Yeah, so problem here is with GraalVM itself, not with...
I would say so, yeah.
Okay, thank you very much.
Any other questions from the audience? Oh, okay.
Thanks. Is it working?
I hope so.
Yeah, so first of all, great presentation. It's I've been in the area for also around, I don't know, 10 years, and it's still some of the things you said here. I'm not sure I understand, but yeah, it was great. First question is, what font did you use in the presentation? And the second question is, why WASM, WebAssembly specifically?
Why WASM?
Yeah, for this
That's a
technology.
great one, but I probably should make another talk on that one. Because like WASM is, it's a binary representation of it's basically like native code. So it's fast, doesn't need to pre-compile, doesn't need like a JIT stuff, but it also is completely, I'm losing words. It's completely safe, right? Because it's wrapped in a runtime still. So issues, for example, you have with, I didn't talk about this in the presentation, but another point, if I had to add another point to the presentation, it would be security. Because the actual capability providers that are running, or like the actors, they actually have to request or like claim a permission to, for example, the file system. And they do it via the contract as well. So, for example, if you're running these, that's like, if you compare to JVM, if you run a JVM, it has access to the full computer, right? Sorry. Whereas with WASM, you just give it, access to this folder. You can imagine if you have like iPhone, or because I don't know Android, but there's always this request. This application wants to send you notifications. Do you allow? So it's this mechanism. Yeah.
Okay, thanks. Do you have any more questions on WASM, Rust, Singularity?
Yeah, I'll be in the pub.
Okay. Okay, one more.
Maybe one more question regarding the Hello World example that you showed. By the way, it was awesome. I liked it a lot. Imagine that you wanted to make a change in there right now in a live demo. You have to compile it first, right? And so my question is, if you wanted to change something and show it to us, how many minutes would it take? Or
I can do it.
Because you mentioned that the compilation time is maybe a problem, but probably not for Hello
we'll
World.
So, for example, we do what? We change this, right? Hello, change. Is that enough? Sure. Now I saved it. Now I have to recompile. Done. Now I can upload it to the runtime, and it's going to hot swap it.
Nice. So, Roman, thanks so much for the presentation. It was awesome.
Thank you.
So, ladies and gentlemen, this concludes our crew talk, but there is still a lot of food to be eaten, a lot of beer that needs to be drank. Thank you. I'm very good at English, obviously. And then at 8:30 or 20:30, I will be giving a personal tours through our offices, whoever is interested. So we will meet. I will announce it, and we can then meet that here at the doors. And yeah, have fun. We will be here till 10, and afterwards we can go to the pub. Thanks to all, and have a great night.